When we look up at the night sky, we see a vast, dark canvas. It is decorated with countless points of light. We have always wondered, are we alone in this immense cosmos? For centuries, our search for life beyond Earth focused on a simple idea. We looked for planets like our own, worlds orbiting their stars at just the right distance. Not too hot and not too cold. This special region is called the habitable zone, or sometimes the Goldilocks zone. It is where liquid water, the very essence of life as we know it, could exist on a planet's surface. But what if this is only a small part of the story? What if life doesn't need the warm kiss of a nearby star to begin? The universe is full of surprises. It often works in ways we are only just beginning to understand. We are now discovering that the most promising places for life might not be the sun-drenched worlds we once imagined. Instead, they could be cold, distant moons, far from the warmth of any star. These worlds appear frozen and dead from the outside. They are encased in thick shells of ice, seemingly barren and inhospitable. But beneath these frozen surfaces, a powerful and hidden force could be at work. A secret engine, generating enough heat to create vast, hidden oceans of liquid water, and perhaps to spark the chemistry of life itself. This hidden energy source changes everything we thought we knew about where life could exist. It expands the search for alien worlds far beyond the traditional habitable zone. It suggests that the cosmos might be teeming with life in places we never thought to look. So what is this mysterious force? What is this secret engine that could power life in the cold, dark depths of space? It is a process called tidal heating. You might be familiar with tides on Earth. The rhythmic rise and fall of our oceans are caused by the gravitational pull of our moon. But tidal heating is something far more powerful. It is what happens when a moon orbits a much larger planet, especially when its path is not a perfect circle. This gravitational relationship is not a gentle one. It is an immense and relentless cosmic dance, a constant tug-of-war between celestial bodies. Imagine holding a small rubber ball in your hand and squeezing it over and over again. Your hand is the giant planet, and the ball is the moon. As you squeeze and release, the ball flexes and deforms. This constant motion creates friction inside the ball, and that friction generates heat. Now scale that idea up to the size of a planet. Let's look at Jupiter, the king of our solar system. Orbiting this gas giant is a moon called Europa. From a distance, Europa looks like a cracked billiard ball, its surface a network of long, dark lines crisscrossing a bright, icy shell. For a long time, scientists wondered what could have created these strange features on such a cold world, so far from the sun's warmth. The answer, we now believe, is tidal heating. Europa is locked in a gravitational dance with Jupiter and its other large moons. This cosmic tug-of-war constantly flexes Europa's interior, generating enough heat to maintain a vast ocean of liquid salt water beneath its icy crust. If we travel even farther out, to the majestic ringed planet Saturn, we find another fascinating moon, Enceladus. This tiny moon, only about 500 kilometers across, should be a frozen, inert ball of ice. Yet our Cassini spacecraft made one of the most exciting discoveries in modern space exploration. It saw enormous plumes of water vapor and ice crystals erupting from great fissures near Enceladus's south pole. To truly understand tidal heating, we must first go back to basics. We need to talk about gravity. Gravity is the invisible force that governs the universe. It is the reason we stay on the ground, the reason the moon orbits the Earth, and the reason the Earth orbits the sun. Every object in the cosmos, from the smallest speck of dust to the largest galaxy, pulls on every other object. The strength of gravity's pull depends on two things: mass and distance. A giant planet like Jupiter has an immense gravitational field, more than 300 times stronger than Earth's. But distance also plays a crucial role. The closer you are to an object, the more intensely you feel its gravity. When a small moon orbits a very large planet, the side of the moon closer to the planet feels a much stronger gravitational pull than the side that is farther away. If a moon orbited its planet in a perfect circle, the story would end here. But the universe is rarely so neat and tidy. The orbits of moons are almost never perfect circles. Instead, they follow a path that is slightly oval-shaped or elliptical. An elliptical orbit means the moon's distance from its parent planet is constantly changing. At one point in its orbit, it is closer to the planet. This is called its periapsis. At another point, it is farther away, its apoapsis. As the moon moves along this path, the strength of the planet's gravitational pull changes continuously. This constant change in distance creates a continuous cycle of flexing. So, why are orbits elliptical? Often, it is because of the gravitational influence of other nearby moons. In a system with multiple moons, like the ones around Jupiter and Saturn, the moons are all pulling on each other. This phenomenon is known as orbital resonance. It happens when the orbits of multiple moons are linked in a simple mathematical ratio, keeping their orbits from becoming circular. The final step is to understand how this constant flexing generates heat. The answer is friction. Just like rubbing your hands together on a cold day makes them warm, the internal friction inside a flexing moon generates enormous amounts of heat. As the tidal forces deform the moon, these layers grind past one another. The rock and ice inside the moon resist this deformation. This resistance creates friction on a planetary scale. The immense energy of the moon's orbit, dictated by gravity, is converted directly into thermal energy or heat deep within its interior. This simple, elegant mechanism, born from the fundamental laws of gravity, can turn a small, icy moon into a potential habitat, a warm oasis protected from the harsh radiation of space by a thick shell of ice. An invisible force, acting across millions of kilometers of space, can create a warm, liquid environment on a world that receives almost no sunlight. The Cassini spacecraft was equipped with instruments that could analyze the chemical makeup of gases and dust. On several daring passes, it flew directly through the plumes of Enceladus. It was, in essence, tasting the ocean of another world. The results were astounding. As expected, the primary component was water vapor, but it also found tiny grains of silica sand, salts, and complex organic molecules. The tiny grains of silica are a geological clue. On Earth, silica forms like this only when water at a temperature of at least 90 degrees Celsius interacts with rock. This was strong evidence for active hydrothermal vents on the seafloor of Enceladus. Perhaps the most tantalizing discovery of all was the presence of molecular hydrogen. On Earth, some of the most ancient forms of life are microbes that get their energy by combining hydrogen with carbon dioxide. Enceladus appears to have a habitable environment, complete with a potential food source for life. Tidal heating does not just create a place where life could survive. It creates an environment that might be ideal for life to begin. It provides the water, the materials, the energy, and the stable setting. The constant flexing caused by tidal heating could create hydrothermal vents on an alien moon seafloor. These vents would continuously supply the hidden ocean with a rich cocktail of chemical elements, the raw materials for life. So the recipe for a potentially habitable world seems to be taking shape. It is a complete system, all powered by gravity. Let us dive deeper and imagine what one of these tidally heated oceans might actually be like. They would be utterly alien environments, unlike anything on the surface of Earth. First, they would be completely dark. The thick ice shell, possibly tens of kilometers thick, would block out every photon of light from the distant sun. Any life here would have to evolve in a world of eternal night, relying on different sources of energy to survive. This is life that eats chemicals to survive. On Earth's own ocean floors, far from the reach of the sun, we have found thriving ecosystems clustered around hydrothermal vents. The base of this food chain is not a plant, but a microbe. These tiny organisms take chemicals from the vents and combine them with elements in the seawater, releasing energy to live and grow. This is our best model for what a simple ecosystem on Europa or Enceladus might look like. The entire biosphere would be powered by the geological energy of the moon itself. In a world without light, the sense of sight would be useless. They would have to develop an entirely different suite of senses, finely tuned to their dark, watery environment. The dominant senses would likely be based on touch, taste, and the detection of vibrations or electrical fields. And what about bioluminescence? In a tidally heated ocean, we could see a dazzling display of living lights. Their bodies would be shaped by extreme conditions. Life would likely be gelatinous, or have robust, compact bodies. Perhaps giant, slow-moving grazers roam the seafloor, or colossal predators drift through the mid-ocean. Our journey through the cosmos has brought us to a profound and exhilarating conclusion. For so long, our search for life was guided by the light of stars, but the discovery of tidal heating has shattered this simple view. It has shown us that a second, entirely different kind of habitable zone exists, one that is not defined by light, but by gravity. Giant planets are common throughout our galaxy, and many of them are likely to have families of icy moons. This means that the number of potentially habitable worlds in the cosmos could be far, far greater than we ever imagined. We are not just looking for another Earth anymore. We are looking for Europas and Enceladises. We can now look for the faint heat signatures of tidally active moons, the telltale signs of a gravitational engine that might be powering a hidden living world in the cold and the dark. We stand at a remarkable moment in human history. We have identified real, tangible places in our own solar system where alien life might exist right now. The journey ahead will be long and challenging. We will need to send robotic explorers equipped with instruments of incredible sensitivity, and perhaps one day, landers that can drill through kilometers of ice. The discovery of even a single simple microbe on one of these moons would be the most profound scientific revelation of all time. And so we are left looking up at the sky with new eyes. We see not just points of light, but points of possibility. The gravitational dance of distant worlds reminds us that the universe is more complex, more surprising and more beautiful than we could have imagined. Tidal heating has given us a new map for our quest, pointing the way to hidden realms of unimaginable potential. The ultimate discovery may be waiting for us hidden in the dark.